All right, we are going to be doing relations and functions. We're going to be talking about the combination of what is a relation, what is a function, and how do we determine those. So we're going to start off with a relation. A relation is simply how an input value relates to an output value. So for example, if I said, hey, give me a number and I'm going to add 3 to it. Okay, so a person, let's say, picks a 7. 7 plus 3 is 10. I give you back 10. So if you think of that, the input value would be the 7, the output value would be the 10. Okay, we also have some other names for these. Input values are what is known as the independent variable. Okay, where output values are known as the dependent variable. So in other words, if you think about it, independent, I'm putting a 7 in. I could have chose any number, but dependent on what number you choose, when I add 3 to it, I am dependent on what number you choose to give back. So therefore, independent, dependent. We also give it a very strong name called domain. Normally, the independent variable is the domain. Normally, it is X, whereas the output is the dependent, and it is called the range, which is normally Y. Now, we have 4 ways to write a relation. One of those is a set of ordered pairs. We just go through and we write those down. We have set brackets on each side. Remember, our ordered pairs are always of the form X comma Y. Okay, so we put those into an ordered pair format. Another way we can do it is a T-table, where we just write all the X's, the input values, the Y values, and then we make those link together. The third one is the mapping. This would be our inputs. This would be our outputs. And we draw an arrow to those of how they connect. And then the fourth way is a graph. We can draw a picture here and put a dot everywhere where we would have one of these ordered pairs. Now, what's the difference between a relation and a function? Now, a function is just simply a special relation. So it is where every domain or input maps to exactly one range output. So in other words, if you think about it, every X maps to exactly one Y. So in other words, we can't have an X repeating, okay? So if there are no repeats, then it is a function. If in our domain there is numbers that are repeating, it is not a function. So an easy way to think of that, if in your domain there are no repeating numbers, then it is a function. In your domain, if it has repeating numbers, it is not a function. Okay? Now, we also have this way to do it on a graph, which is a vertical line test. So what that simply means is if we look at a graph and we take a vertical line and slide it across that graph, if the picture ever meets one or more points, so any more than 1 point at a time, then what that does is that makes it not a function. If it meets only 1 point at a time, then it is a function. Okay? Now, so here we go. Let's try a few. We're going to state the domain, the range, and then say why is it a function or not. Okay, so remember, domain is our X values, and range are our Y values. So when we look, we start in and we say, okay, what is the domain? So I'm going to write them in order from least to greatest, so -4, -2, 3, and 5. So there's our domain. So now let's write the range. So we pick off the Y values. So we have -5, -3, 2, and 4. And then the question is this a function, yes or no? Well, to do that, what I simply do is I take a look at my X's. So I have 3, -4, -2, and 5. Now, if you notice, none of those repeat, so is it a function? And the answer would be yes, it is a function. There are no repeating numbers in the domain. Okay, so that's how we determine that. So let's try another one. So if we come over here, We start off, remember, domain is our x values. So we come in here and we say, okay, what's the smallest x? And it would be -4. My next one is -2 and 4. Now notice we have two -2's here, but I only wrote one. I don't write repeating ones. And then my range, remember, are the y values. So we have -11, 0, 7, and 13. Then the question is it a function? So as we highlighted already, my domain has the same number in it. So the answer would be no, it is not a function because -2 repeats, okay? So let's try a t-table here. So if we look, my domain, I'm going to go -4, 0, and 3. My range is my y values. So I go -8, 1, 5, and 8. Then I look, is it a function? Well, if we look at our domains, we have a repeating 3. So the answer would be no, it is not a function because 3 repeats. Okay, here on number 4, we do very similar. We start off and we go -2, -1, 0, and 1. There's our domain, our x values. Then we come back to do our range values, and that would just simply be -5. Now, be very careful here because a lot of people would say this is not a function, but it is a function. And the reason for that is if you look across your domains, all of these x's, if you look at them, none of them are repeating. So this is no repeating domain. Is why? Because every domain maps to exactly one range. Doesn't matter that it's the same range, but they all map to exactly one. Okay, let's try it in a mapping now. So if we start off in the mapping, on this first one here, we have the domains. So we go -1, 0, 1, and 2. And the ranges would be -2, 0, and 2. And then if we ask, is it a function? And the answer would be yes. No domain repeats. Because in a mapping, you would have more than one arrow coming from any number. Okay, let's try the next one with the mapping. Here we start off with the domain. Would be -3, -2, and -1. The range would be 0, 1, and 2. And it says, is this a function? And this would be no because -3 repeats. And the reason I know that is because it has 2 lines coming out of it, so I know it is repeating. Okay, let's take a look at the graph. Now on the graph ones, we're going to start at the left side and we're going to go to the right until we get to a point. So my first one is there, which puts me at -3. My next one I come to is -1. I come over 1, 2, 3. And my last one, 4, 5. So my domain would be -3, -1, 3, and 5. Then I come back to do the range. This time I'm going to start at the bottom and work up. So I would start off and I would have -1. I'd go here, which would be at a +1, 2, 3, 4. And then I have another point up here at 6. And that would be our range. Then it would say, is it a function? And this time, yes, because if I draw vertical lines going through here, and I take that vertical line going across, it's only going to hit one point on our graph at any time. So it passes the vertical line test. All right, now when we look at this problem is just a little different. This time I don't have just 4 different points. I have part of a figure here. So I look at this figure and I say, okay, starting at the leftmost side, where is the least value in that? And it would be right here. And it would keep going, and I could be all of these values until I get to here. Now, that should look familiar to us because the domain here would be at 1, 2, 3, 4, 5, less than or equal to x, less than or equal to 2. So if you look at that picture, the domain has to fall between -5 and a +2. Now, likewise, if we do the range now, the range, the smallest value is here, but the highest value is there. So it would be -2 is less than or equal to y, less than or equal to 1, 2, 3, 4, 5, 6, 7, 8. Then we would ask ourselves, is that a function? Well, if you think about it again, if we look, if I draw a vertical line, and then I take that vertical line and I start tracing it across, and I look at those vertical lines going across. If you notice, at any one vertical line, I'm only hitting 1 point. So yes, it is a function because it passes the vertical line test. Okay? Then we could take and say, okay, let's put this into a story problem. So if I have a function described by 1 equals -0.5x plus 12, represents the amount y in ounces of toothpaste remaining after you brush your teeth x number of times. So when we look at this, the independent variable, and what does it mean? Remember, independent variable is the part that drives the equation. It's the part that we could pick any value, and the dependent variable is the one that gets returned no matter what we plug in. So when we think about this, we start looking for important information. And some of the important information is we have our equation here. We have what y is, and we have what x is. So when you think about this, when you go to brush your teeth, does the amount of toothpaste in the tube affect how many times you can brush? Or does brushing your teeth cause you to lose more toothpaste in the tube? And the answer would be the second one. So the independent variable would be the x, which is the number of times. So the number of times you're brushing your teeth. The dependent then would be your y, which is the ounces of toothpaste left. So now if I said, okay, what's the domain and range? So if I brushed my teeth 1 time, so I take that and I would plug it in for the x, and I add 12 to that. Well, -0.5 times 1 is -0.5. Add it to 12. We would get 11.5 ounces left. Then I'd come back and say, okay, what if I brushed my teeth 4 times? Well, half of 4 is 2, so -2 plus 10. So now I'm down to 10 ounces. So then I'd come back in, I'd plug in the -5 to the 8. So -0.5 times 8 plus 12, which gives me -4 plus 8, 12, which is 8 ounces. And my last one, I go -0.5 times the 13, add the 12 to it. That's going to give me -6.5, add 12. That would be 5.5 ounces. So using that function equation, we can actually determine how many ounces would be left in our toothpaste tube. Okay, last one. State whether it's a function or not. So what we're going to do here is we're literally just going to do our vertical line test. So if you imagine of a vertical line kind of going through here, how many points is it touching on that green graph? And on that one, it's only touching it once. So we would say, yes, this is a function. Okay, let's take a look at number 11. Same thing. If I draw my vertical lines in here, that's all going down, only touching at one spot. So yes, that is also a function. Now take a look at number 12. If I draw my vertical lines in, you'll notice even on this very first one, I'm hitting it in 2 spots. So we would say, no, that is not a function by the vertical line test. And on this last one, if I drew my vertical lines in, I keep going, you'll notice I'm not hitting any more than 1. So we say, yes, that is a function. And what we just did there is talking about our relations and our functions.